In this lesson, you will be able to 1. Illustrate quadratic equations, and 2. Solve quadratic equations by extracting square roots and factoring. In this part, let us define a quadratic equation in one variable. It is an equation of degree of 2, and its standard form is a x squared plus bx plus c equals 0, where a, b, and c are real numbers, but a is not equal to 0, and x is the variable. Quadratic equations may be written in various forms. As you notice, a quadratic equation is an equation in which the highest power of the variable is 2. Now as we move on, working with a quadratic is usually simplified when the quadratic equation is written in standard form. A x squared plus bx plus c equals 0. For the first example, we will write each quadratic equation in standard form and determine a, b, and c. Given the first equation, 5x squared plus 3x equals 7. To be able to make it a standard form, you have to subtract -7 from both sides to eliminate 7 in the right-hand side of our equation. Finally, we have 5x squared plus 3x minus 7 equals 0, where a is equal to 5, b is 3, and c equals -7. There you have it. Now let's proceed to the next example. Given the 2x squared equals -8x, how do we write it into standard form? As you can see, the given is the first term, 2x squared. We can just write it down here. The next thing that we need to do is to eliminate -8x on the right-hand side of our equation. For us to do that, we will add 8x both sides. There you have it. We have the first term, 2x squared plus 8x. Good to go, but there is missing, right? We don't have the constant term, but still we can identify a, which is 2, b equals 8, and c. Since it is missing, then it became 0. Did you get it? Now it would be great if we could try your skills in the following given here. Try the following and write quadratic equation in standard form and determine a, b, and c. You can pause this video and try writing the following example given in the first part of our lesson and try answering these questions. Once done, do not forget to verify your answer to your teacher. You know what? There are several ways to solve quadratic equations. The first one is by extracting the square root. The second would be factoring. Third, you can also visualize the quadratic equation by graphing. You can also use Desmos or GeoGebra to visualize it, or we could do it manually. The fourth method would be completing the square. And finally, the most convenient one, the use of quadratic formula. And now, we will be diving into the first method, solving quadratic equations by extracting square roots. I suggest you familiarize yourself to this important rule or principle governing this method. The square root principle. This rule is basically saying that if x squared is equal to a and a is greater than or equal to 0, then there are two possible answers, or I should say roots in other term. It will become x equals square root of a, or x equals the negative square root of a. As you can see, the possible answers can be positive or negative of a square root of the given constant. For example, if x squared is equal to 25, then identifying the a, which is 25 in this case. Using the square root principle, then we have x equals plus or minus the square root of 25. Simplifying this will give us plus or minus 5. As E further discuss, the square root principle is useful in solving quadratic equations of the form x squared equals c, when c is not a perfect square and c is real. For our next sets of example, we need to solve quadratic equations by extracting square roots. Let us solve for x for the first given x squared equals 49. Applying the rule for square root principle will make our lives easier here. We write x equals plus or minus square root of c, which is 49 in this case. Then we have to simplify the radical. Since 49 is a perfect square number, it will be easy for us. Square root of 49 is 7. Finally, we have x equals plus or minus 7. You can also use the term positive or -7 as well, if you insist. Therefore, the two solutions are +7 and -7. There you have it. Moving on to the next example, given m squared plus 3 equals 51. Now what? This one is a bit different, but we can just subtract 3 from both sides to eliminate 3 from the left-hand side of our equation, leaving us m squared equals 48. As you can see, we can now apply the square root principle. Then it would become m equals plus or minus square root of 48. As you can see, 48 is not a perfect square, right? So the thing we need to do here is to factor the radicand. Can you find the two numbers if we multiply them will give us 48? Take a moment to pause this video and think about it. There you have it. The two factors are 16 and 3. As we continue, we write m equals plus or minus square root of 16 times 3. We know we can simplify this one, right? The thing that we can do here is to simplify the radicand. Then we have square root of 16 is 4. Then we write 4 outside the radical symbol. Square of 3 is just the same. Why? Because 3 is not a perfect square number. So it will remain. There you go. After following right process, we have the final solution of m equals plus or minus 4 square root of 3. If you come this far, you are doing great. Let us try the third given example. 4x squared minus 9 equals 71. The thing is, we need to eliminate the negative 9 on the left-hand side by adding 9 to both sides. This will left us 4x squared equals 80. As you can see, we can isolate the x here. By dividing both sides by 4, now we can have x squared equals 20. Now we can apply the square root principle, and this will left us x equals plus or minus the square root of c, or constant, which is 20. Since 20 is not a perfect square number, we can factor the radicand. We can use the product of 4 and 5, right? So we write x equals plus or minus square root of 4 times 5. Then, finally, as we simplify the radical, square root of 4 will give us 2 outside the radical symbol. Square root of 5 will remain. So our final solution are x equals plus or minus 2 square root of 5. Alright, let's have our final example before the activity. In this case, we have 5x minus 3 quantity squared equals negative 32. How can we solve this? First is to apply immediately the square root principle, since the two terms are bounded by square. Using it gives us 5x minus 3 on the left-hand side equals plus or minus square root of negative 32. The fact that there is still 3 on the left-hand side, we have to add 3 both sides to eliminate it. After doing it, the remaining would be 5x equals plus or minus square root of negative 32 plus 3. We have to isolate x here, so we divide 5 both sides, giving us x equals plus or minus square root of negative 32 plus 3 all over 5. We know that there is a factor of negative 32 that has a perfect square number. It can be positive. Can you guess that? Take a moment to pause this lesson to think about it. Very good. We can use 16 and negative 2. Then as write our next process, we have x equals plus or minus 4 square root of negative 2 plus 3 all over 5. What can we notice here is the fact that there is a negative number. We all know that this number is not a real number. Therefore, if you encounter this one, therefore we can conclude that there is no real number solution to the given equation. You've completed the first 4 examples for extracting square root for quadratic equation. Now it's your turn. Practice makes progress. You could try the following given to solve for x. Take a moment to pause and review the previous example, and write all the necessary process to your notebook for your reference. And now, we can proceed to the next part of our lesson. The second way of solving quadratic equations, and it is by factoring. You know what? We have procedure in solving quadratic equations by factoring. Following these steps will guide you along the way.